We're starting our new unit, which is exponential functions. Okay, we talked about quadratics earlier. Quadratics, they are the function that would have a parabola. Exponential functions is a little bit different. We're going to start with the exponents law, which we have seen some of them as we are simplifying, multiplying, and as we are factoring. We have seen some of them, but this is a little bit more advanced. Now, question to you guys. What does it mean if I write a of 3? What does that mean? A times A times A 3 times. So this is what it means. Yeah? But instead of writing it this way, I just write it a to the power of 3 because it's less time, less effort, less things, less space, everything. Right? Make things more condensed. Right? So we're going to see what happens if I have, let's say, a cubed multiplied by a to the power of 4. What happens? How can I do this? So things that you have to be careful with, or you have to remember, is we have what we call the term. So let's say this is my term. What do we call this? What do we call that number 2? What's the vocabulary for it? It starts with a C. Coefficient. So this is your coefficient. So it's a number that comes before the variable. Okay? The variable in this case is your, what do we call it? The variable is your base, right? And the power is your exponent or power, right? So this is in a term. You have the coefficient, you have the base, and you have the exponent. Now, when I'm simplifying, okay, let's see what happens. When I'm multiplying, when I'm dividing, all of these, what's going to happen? So let's start with the first law, which is the multiplication law. Okay? So if I have a to the power of 4 times a to the power of 5, I would write this. For a to the power of 4, I would write a times a times a times a. Yes? Then I have the multiplication, which you see right here. Then you have this multiplication. Then you have a to the power of 5, which is a times a times a times a times a. Yes? So how many a's are multiplied together? 9. So how can I write that instead of writing a times 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 a? A to the power of 9. Okay? All right. So let's do the second one. So I have a to the power of 2. So I can write this as a times a. Then I have this multiplication. So I have to write it. And I have a to the power of 4. So that's a times a times a times a. That's 4 times. So altogether, how many a's are multiplied together? So that's a to the power of 6. How about the next one? So how many a's I have first? 5. And then multiplied by, I'm missing one a. And then multiplied by a. So how many a's do I have multiplied together? 6. Next one, I have a times a times a times a. 1, 2, 3, 4, 5, 6. And then I have to multiply by a times a. So altogether I have a to the power of 8. Have you noticed anything so far?
Yeah, adding up the exponent.
Yeah, we're adding the exponent. right? We're keeping the base. The base is staying. The base is going to stay a, but then if I do 6 plus 2, that gives me 8. 5 plus 1, that gives me 6. 4 plus 2, that gives me 6. 5 plus 4, that gives me 9. So all what I'm doing is I'm keeping the base. Now in this case, I have the same base. So both bases are a, right? So I'm keeping the base, and I am adding the exponent. So that would be 4 plus 3, which is a to the power of 7. Right? So instead of me writing this, a times a times a times a times a times a, you know, I can simply just keep the base, add the exponent. Okay? This is called the multiplication law. So if you see right here, the product rule, right, where you have the same base, you're multiplying them. What you do, you keep the base, you add the exponent. So the rule is, we're going to write the rule in terms of letters. Keep the like base and add the exponents. So if I have A or B or whatever you want to have the base to the power of m times A to the power of n, I keep my base, which is A, and then I add the exponent. Does that make sense?
We can say m n.
No, it's multiplication. It's m plus n. What is it? This is just in general. So whatever your exponent is, could be 3 and 7, could be 5 and 2. It's just in general. It's a general. You know how we used to write ax squared plus bx plus c, where a, b, and c are numbers? M and n here are any number. Number.
So it would never be
Not yet. No. 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 Okay? So in these cases, your m and n, they are actually numbers, whole numbers, and then you're going to add them. Okay? So an example would be what we just saw. So instead of m, it's 4. And then instead of n, let's say it's 3. Right? So what you do is you keep the base, and then you add your exponent, which is 4 plus 3, which gives you a to the power of 7. Okay? It's just we use m and n as the general term. Okay? Are we okay with this?
Yeah.
So we call this the multiplication law or the product law. Okay? There's different names for it. It means the same thing. Now, we're going to look at the division law. Okay? So does this work, what we just did? Does it work if I have this? No. Why not? The base are not the same. Okay? I can't just add the exponent here. They're not the same. Okay? This can't be simplified. It has to stay like this. A to the power of 5, b to the power of 2. You can write it as a to the power of 5, b to the power of 2. That's it. You can't write it like this. That's it. There's nothing you can do with this. Okay? Because your bases are not the same.
So your base would always be the same, right?
The base have to always be the same in order for you to be able to use the multiplication law. Are we clear with this? All right. Now, what happens if I have division? So I have a to the power of 5 divided by a to the power of 4. So I write a multiplied by a 5 times divided by a multiplied by a 4 times. So if you look here, what I can do is I can go, okay, 1 and 1 they cross because we always simplify one from the top, one from the bottom when there's multiplication. When there's multiplication and division. So 1 from the top, 1 from the bottom, 1 from the top, 1 from the bottom, 1 from the top, 1 from the bottom. What am I left with? A to the power of 1. It's not 1. It's not. It's A to the power of 1. Okay? That's you can leave it as A. All right. Now let's simplify this one. So I have A times A times A times A divided by A times A. Simplify. 1 from the top, 1 from the bottom, 1 from the top, 1 from the bottom. What am I left with?
A to the power of 2.
A to the power of 2 because it's A times A, which is A to the power of 2. Let's write this one. So I have A times A times A times A times A divided by A to the power of 4. So if I cancel this and this, I'll be left with A to the power of 4. Can you tell me what would be the answer for the next one? A to the power of 4. How did you get that? 6 minus 2. So we are subtracting the exponents now, right? Because we are reducing. Good. So in this case, I'm going to keep the same base. And I'm going to subtract my exponent. So 6 minus 2. So that gives me A to the power of 4. Right? If I do this, I should get A to the power of 4. Let's see. A times A times A times A times A times A divided by A times A. Cancel, 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 cancel. You'll be left with A to the power of 4. Okay? What would be your answer for this one? A to the power of 1 or just A? Because if I subtract 4 minus 3, that gives me A to the power of 1. Again, you must have the same base. Okay? You keep your base, you subtract your exponent. Are we good with that?
What if the first, because there's two, what if the first has a lower exponent than the second one?
We'll talk about that in a bit. You're going to end up with a negative exponent. We're going to talk about how to simplify that after. Okay? So the question is, what if I have A to the power of 3 divided by A to the power of 2, for example? Sorry, not that. A to the power of 4. Right? So if you have something like this, you're going to end up with A3 minus 4, which is A to the power of negative 1. What do I do after that? There is a whole table about that. We're going to talk about it. Okay? All right, so the rule right now with the division law is first, you're going to keep the like base, and then you're going to subtract the exponent. So if you were to write this as a general term or as a general formula, what would you write? So A to the power of m divided by A to the power of n equals to A m minus n. Are we good with that? Is it clear? Can I move to the next one? So now we're going to move to the power of a power law. Okay? So in this case, I have one base. Eyes on me for a second. So I have a to the power of 4. Then I raise that to the power of 5. Okay? So that being said, that's the same thing as saying that I have a to the power of 4 5 times. Right? So I have a to the power of 4, 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 a to the power of 4. So they're all multiplied together. Right? Now I can go and expand each one of them. Do we want to do that? A times A times A times A times A times A. Okay, no, we don't. What did we learn about the product rule? What do we do with the exponent? We add them. Okay, so we have 4 plus 4 plus 4 plus 4 plus 4. So that's 20. So that's a to the power of 20. Yes? Okay. So I have a to the power of 2 and then also to the power of 3. So I have a to the power of 2 times a to the power of 2 times a to the power of 2. So that's a to the power of 6. How would I write this as expanded form? A to the power of, which is? Any idea what's happening here? Multiplying the exponent. That's right. So, a to the power of 6 times a to the power of 6 times a to the power of 6. So that gives me a to the power of 18. I can simply say 6 times 3 is 18. Right? So in this case, it's going to be a to the power of 4 times 3. So that's a to the power of 12. Okay? So when we have power to the power, we multiply the exponents. Are we all clear with that? So again, you're going to keep your base. There's only one base in this case, so we're going to keep the base. And then we are going to multiply the exponent. So in this case, if I have a, I have one base to the power of m to the power of n, right? I have to write it as base a and then m times n. Okay, I want you to take a couple minutes to try example 1 and then we'll take it up.